Setting up the Raspberry Pi to connect to our endpoint. In this module, we're going to set up a Raspberry Pi to send some weather data to our endpoint. We're going to use a couple of sensors that are already familiar to you from other modules in this course. We are going to install an AM2302, a BMP180, then we're going to create a script that gathers data from both of those devices, and then we're going to send that data to our endpoint. So let's get started. If you completed other modules in this course, you'll know that we've already set up these devices individually, but now that we're running them together, the wiring is a little bit different. Here's the first diagram for the BMP180. As you can see, we have a 3.3 volt at pin 1, SDA at pin 3, SCL at pin 5, and then ground at pin 6. And for the AM2302, we have the I/O wire going into pin 7, we have a ground going into pin 9, and then we have a 3.3 volt positive going into pin 17. And this is the physical layout of our Pi that we're going to be using for this exercise. It should look something like this when you get it wired up. So, now that we've got it all wired up, let's install our devices. Now I'm here on my Raspberry Pi, and I'm going to be setting this up locally. You can also SSH into your Pi if you choose to, or you can go to the Pi desktop as we're doing here. First, we're going to set up our AM2302. We're going to do that in a similar fashion as we did in previous modules. First, we need to clone the DHT library from Adafruit. And we're going to do this with the following command. And now that that's been cloned, let's go ahead and cd into that directory. Next, we need to install some prerequisites. So to do that, we're going to do an upgrade, and then we're going to install a couple of things. So we'll type in sudo apt-get upgrade. And it shows there's nothing to upgrade. So now let's install those prerequisites. And here we're doing a sudo apt-get install build-essentials python dev. We'll select yes to continue. And now that we've got those installed, let's go ahead and run the installer. We do that by running sudo python setup.py install. Okay, and it looks like it installed successfully. And now let's do a quick test. We'll want to cd into the examples folder. And then we'll use the following command to do a quick test. We'll use sudo python adafruitdht.py 2302 and 4. And 4 is the pin that we're using. And as you can see with the temperature and humidity displaying there, that we have it wired up properly and we have the drivers and software installed properly. Next, we'll install the BMP180. Now to set up the BMP180, we're going to have to do what we did in previous modules, and we'll have to set up I2C for the Raspberry Pi. We'll start by running the following commands. The first one is sudo apt-get install python-sm bus. And now that we've got that installed, let's go ahead and install our I2C tools. And we do that by typing in sudo apt-get install I2C-tools. And it shows that I2C tools are already installed. Sometimes these are installed default with Raspbian, but you may need to install it manually in some distributions. And now we want to install I2C support for the ARM core and Linux kernel. So here's how we'll do it. Type in sudo raspi-config. And this is the Raspberry Pi configuration utility. Scroll down to Advanced Options. Scroll down to I2C, and it asks, would you like the ARM I2C interface to be enabled? Select yes. And as you can see, we'll need to reboot in order for that to take effect. It asks if you would like the I2C kernel module to be loaded by default. We're going to select yes in this case, because we want it to load up every time we reboot the Pi. It's going to ask if you'd like to reboot, and we'll select yes. Next, we're going to want to make sure that the right modules are loaded by default. Type in sudo nano etc modules. And as you can see here, we already have I2C-dev. Sometimes that won't be there, but we want to add an additional one here. We're going to add in I2C-BCM2708. Make sure that both of these lines are added to your etc modules, and then save and exit. Next, we're going to want to edit our boot config. Scroll down all the way to the bottom of your boot config file. As you can see, we have dt_param equals I2C underscore arm equals on. This was added automatically, but if it wasn't added, you do need to add this to your file. And then we're going to add an additional line as well. We want to add dt_param equals I2C1 equals on. Now we want to save and exit and reboot the Pi again. Okay, now we want to verify that our device is connected properly and the drivers are installed. So here's what you'll type in. Sudo I2C-detect-y space 1. Now you see the number at column 7, line 70, where it says 77? That indicates that we have a device on the bus. You should see a number somewhere in this matrix in order to show that your device is properly connected. Now if you don't see it, try changing the 1 to a 0. Depending on the Raspberry Pi, you may have one that's set at 0 and you may have one that's set at 1. Now we're going to hook up the Adafruit BMP library. The Adafruit BMP library is a handy library for interacting with our BMP 180, and it's provided by the fine folks at Adafruit. To install it, we'll run the following commands. We'll run sudo apt-get update again. Now that we're updated, we should be able to clone that repo and run it. So let's do that. To clone this repo, we'll type in git clone https://github.com/adafruit/adafruit_python_bmp.git. And now let's go ahead and cd into that repo. Now in here, we want to run the installer. To do that, we'll type in sudo python setup.py install. Now once these are all installed, let's go into the examples folder, and we'll run a simple test. To do that, we run sudo python simpletest.py. Congratulations, we've got it hooked up, and as you can see here, we have temperature, pressure, altitude, and sea level pressure. This is exactly what we expect to get out of this sensor, so we know that both sensors now are hooked up and receiving data. Next, we're going to create a script to read those values and send it off to our endpoint. Now we're going to write a script to read both of the sensors and send it to the endpoint. While that may seem complex, the code to do it is actually pretty straightforward. To create a file, type in nano-readings.py. And first, we want to import some of the libraries that we're going to be using. As you can see, we have the Adafruit DHT library and the BMP library, as well as URL-lib and URL-lib2. Next, we're going to set a few values. These are values we may need to change later, so it's a good idea to keep them at the top and put them into string variables. In this example, URL is the URL of the endpoint that we're going to set up. If you set up the endpoint on your Pi, it can be localhost. In my case, it's going to be internetofthings.jeremymorgan.com. Sensor is the BMP 180, and the library we're going to use is the BMP 085 library. Sensor 2 is the AM2302, and we'll use the DHT22 library for that, because the DHT22 is actually the chip that's embedded in the case, and once it's encased, that makes it an AM2302. And pin is the pin number where our orange data wire from the AM2302 goes to, which in our case is 4. And now let's set up some actions. As you can see here, we're reading these values from the AM2302 into variables that we're going to use later. We have temp1, which reads the temperature, pressure, and sea level pressure are all going to be read from this device into these variables. Now we're going to read two more values from the AM2302, humidity and temp2. Since we're already getting temp1, we want to get temp2 from the other device, and then what we're going to do is we're going to combine those and average them. Okay, so I've added a line here, temp average equals temp1 plus temp2 divided by 2. Now you might want to exercise some caution with this, because if one of the temperatures is way out of whack, it's going to offset it and it's going to give it an accurate temperature, but it may not be visible unless it's way, way off. So you want to check temp1 and temp2 and make sure those temperatures are relatively close, within a degree of each other at least. And now we're going to assemble all this data that we're gathering into a JSON packet. As you can see here, we're creating an object called data. We've got temp1, temp2, temp average, pressure, sea level pressure, and humidity. These are all of the values that we're going to be sending to our endpoint. Next, we're going to add an object called headers. that has a connection, which equals keep alive, and content type, which is application JSON. And this is going to be the headers that we're going to send with each request that we send in to our endpoint, so it knows what type of data to expect. Next, we want to make sure that this data is converted into JSON. So how we're going to do that is we're going to take that data object, run it through json.dumps into a string URL called URL data. Finally, we're going to open up the request and capture the response. We'll use the following code to do that. Now here we're going to send out a request with URL lib2. We're going to use that by taking the URL data that we formatted earlier, the JSON, and then the headers that we want to send with it. And we're going to combine that all with URL lib2.request. And we're going to put that into the request object, or REQ. A response is going to be the URL lib2.urlopen function, and it's going to open that request and then return a response to the response variable. And then for the page, the_page, we have a response read so that it reads that response out. Now our script is ready to send data to the endpoint. So let's try it out. In this module, we installed an AM2302, we installed a BMP180, and then we created a script to gather data from both of those devices. And we set it up to send that data to our endpoint. Most of the code for this exercise was already written, most of it by Adafruit. So this is pretty easy setup for most beginners, and I hope this module has shown you how easy it is to get started. Next, we're going to tie it all together.